Hello, welcome in the video number 1 on the topic Introduction to Analytical Chemistry, which belongs to paper number 4. So in this topic Introduction to Analytical Chemistry, the first question that arises in your mind may be why it is essential to study this topic, or what is the scope of this topic, or what sort of information, what sort of knowledge we can obtain after discussing this topic. So let us first discuss the scope of this topic. The first and important point we can achieve, we can get the knowledge of analytical chemistry. So after discussing this topic, after studying this topic, we can acquire the analytical knowledge of analyzing the samples or solutions or different compounds. The second important scope of this topic, let's skip this one first. Second important scope is to understand the analytical processes. So in chemistry especially, we analyze different samples, different solutions. We find out the concentration or the normality and molarity of the given solutions. We have been supplied organic compounds, unknown organic compounds, and we have to identify which is the given organic compound. So after applying different analytical processes, after adopting different techniques, we find out the concentration of the given solution. We can find out the normality of that solution. Further, we can find out the amount of a particular element present in organic compound. We can find out the elements that are present in the organic compound. So for this analysis we require different analytical processes. So after studying this topic, we come to know different analytical processes which are generally applied in the analysis of different compounds. So this is the another scope. The next scope of this topic, we get acquainted, we get familiar with the methods of analysis. Once we have the sample under analysis, the sample under analysis or the sample which is to be analyzed is called as analyte. If we have the analyte with us and we have to find out the elements present in the analyte, so we have to apply different methods of analysis. So this analysis is of two types. We can carry out qualitative analysis, we can carry out quantitative analysis. So after qualitative and quantitative analysis, we come to know the structure, the amount of elements present in organic compound. So this is how we arrive at the structure of organic compound or the elements that are present in the organic compound. And for all these analysis, we require to adopt some methods. So particular methods are there for the analysis of particular elements. So here we get familiar with the different methods of analysis after studying this topic, depending upon the nature of property that we have to analyze, depending upon the nature of parameter that we are analyzing. These methods will vary, and by selecting a proper method we can analyze the given analyte properly. So this is the scope of the study of this analytical chemistry topic. And after studying this topic, we acquire the analytical skill. Our hand the practical hand is developed in nice way. So analytical skills, so if we have 100 students carrying same performing same experiment, then all the students are not getting the proper results, because their analytical skill vary from person to person. So we can acquire, we can develop the analytical skill after studying the ins and outs of this topic, analytical chemistry. So this is the scope of this analytical chemistry. And once we once we acquire the analytical skills, the analytical knowledge, the different analytical processes that are used for analysis of different samples and different methods of analysis, it will be easy, it will become the nice impression in the interview, and we can get the job in any industry if we have this knowledge about this topic, analytical chemistry. So this is the scope of the topic, analytical chemistry. Now let's discuss the content or the syllabus that we are going to discuss under this topic, or the points that have been mentioned under this topic. So the first is introduction. So we are going to see the introductory part of this, introduction of this topic, analytical chemistry. Second, importance of analysis. Why analysis is essential? What is the importance of analyzing the given samples? What sort of information we can obtain after analyzing the sample? So all these points we are going to discuss under the point, importance of analysis. The third point, analytical processes. So as I mentioned, different analytical processes are there. So mainly qualitative and quantitative analysis or processes are there. Remember, qualitative means just identification or detection, and quantitative means to find out the amount of the element or constituents present in the given sample, which is called as analyte. So for estimation of the elements or the constituents, or determination of percentage of elements or constituents from the sample, is also called as quantitative analysis. The word quantitative means quantity, to find out quantity. So these are the analytical processes we are going to discuss under this point, qualitative and quantitative processes. The next point that we have to discuss, methods of analysis. So there are different methods, as I mentioned earlier, for the analyzing the sample. So we are going to discuss only the classification of the methods that are used in analytical chemistry. So these 3 points we are going to discuss in video number 1 today. The next point, sampling of solids, liquids and gases. So when we analyze particular sample, that may be in solid form, liquid form or gaseous form, so how to collect these samples, solids, liquids or gases, and how to analyze these samples, that comes under this point, sampling of solids, liquids and gases. Next, errors. As we are aware of the thing, errors. If 10 students are carrying out same experiment, 10 students will have 10 different readings. Actually there must be similar reading, but this is not observed. So errors are there. So errors are of different types: personal error, instrumental error, then the methods that is employed, that method can also have an error. So under this errors we are going to discuss types of errors. Mainly we are going to discuss 2 types: determinate error and indeterminate errors. Next point, methods of expressing accuracy. So accuracy is important. If we perform the same experiment for 5 times, 10 times, then the readings should be similar one. The readings should be similar one. So this indicates there is accuracy in method, there is accuracy in person's skill, there is accuracy about the chemicals. So there are different parameters that comes under accuracy that decides the accuracy of the experiment or the analysis. Here we are going to discuss the absolute and relative errors, absolute and relative errors, which minimizes the which increases the accuracy of the readings. And lastly, significant figures like mean, median, standard deviation, and in the end of this topic we are discussing some numerical problems related with the mean, median, standard deviation. So this is about the content or the syllabus that we are going to discuss under this topic, analytical chemistry. Now let's begin with the actual syllabus. The first part is introduction. Now what is meant by analytical chemistry? It is the science of chemical identification and determination of composition of substances and materials and their structure. So as we have mentioned earlier, when we carry out the analysis, so all that analysis comes under analytical chemistry. So how we can define analytical chemistry? It is the science of chemical identification. We are identifying which chemicals, which elements, which constituents, which substances are present in the given analyte. After identification, we have to determine to what extent these constituents, elements are there, and what is the composition of the analyte, and in the end we can find out we can identify the structures of these constituents or the nature of the elements which are present in these which are present in the analyte. So this is the definition of analytical chemistry: the science of chemical identification and determination of composition of substances and materials and their structure. So it is a interdisciplinary science. So analytical chemistry is not restricted to chemistry only. So analytical chemistry is applied, analysis is applied in different fields along with chemistry. So in this science, in this analytical chemistry, which is a science, qualitative and quantitative analysis of compound and structure analysis is carried out, that we have mentioned earlier. Qualitative analysis as well as quantitative analysis is carried out, and finally we can determine the structure of the analyte or the structure of the constituents that are present in the analyte. So this analytical chemistry has wide applications in various fields. For example, it is used in agriculture science, it is used in environmental sciences, oceanography, biomedical sciences, forensic sciences, clinical chemistry, solid state research, in botany, in zoology. There is in chemical industry, lot of areas are there which in which this analytical chemistry is used for the analysis of different samples, which we are called as analyte. Now what is the importance of analysis? Why it is essential to analyze the particular sample? What sort of information we can obtain after analyzing the sample? So in medical sciences, so before discussing this point, let's discuss the importance of analysis with respect to chemistry. Suppose you have given organic compound, or suppose you have given a mixture containing two ions. One is positive ion and second one is negative ion. In other words, it is called as cation and anion. So after carrying out different tests, we can find out two ions. One is positive ion and another one is negative ion. For example, Na plus sodium chloride sample is given to you, and you have been asked to analyze this sample and to find out the ions that are present in this sample. So after carrying out a different test, you come to know in this sample there is Na plus ion and Cl minus ion. So this is nothing but the detection of the ions, which is nothing but the qualitative analysis. Then we can find out the quantity of Na plus and Cl minus. So when we when we carry out particular method for finding out the amount of Na plus and Cl minus, we come to know the amount of Na plus and Cl minus. So when we find out the amount, when we determine the amount of Na plus and Cl minus, then that is called as quantitative analysis. So this is the case in chemistry. If we have organic compound, unknown organic compound, then we have to find out first which elements are present in that organic compound. Then detection of elements or identification of elements is nothing but the qualitative analysis, which is the first step in the analysis of organic compound. The second step is quantitative analysis. In quantitative analysis, suppose these carbon and hydrogen elements are present or detected from the organic compound. In the quantitative analysis, that is step number 2, we have to find out the amount of carbon and hydrogen. We have to find out the percentage of carbon and hydrogen. So this is called as quantitative analysis. Thereafter we can find out the empirical formula. Then by adopting a suitable method, we can find out the molecular weight of carbon, the amount of carbon and the percentage of carbon and hydrogen, and ultimately we find out the structure of that organic compound. So this is the analysis of that organic compound. Similarly, in different fields, this analysis plays the important role. If we consider the medical science field, in medical sciences, instead of relying only on the symptoms, suppose a patient when comes to the doctor, just by looking at the symptoms, doctor cannot prescribe or cannot adopt a proper treatment. But if doctor gets some chemical and instrumental reports in which chemical and instrumental analysis have been carried out, then looking at this analysis, doctor can use a better treatment to treat that patient. So this is the importance of the analysis or analytical chemistry in medical sciences. In industries also, qualitative and quantitative analysis improves the purity and also the yield of production. The purity of organic compound plays the important role, and every consumer gives the importance to the purity. At the same time, he needs the higher yield of the product. So purity and higher yield of the product in industry can be maintained by analyzing, by adopting a advanced technique for the preparation of different chemicals. Chemical analysis is helpful in the diagnosis of metabolic diseases. So out of different metabolic processes are going on in our body. So with these metabolic processes, some disorders may occur that may cause to the metabolic diseases. So chemical analysis plays the important role, and it helps in the diagnosis of metabolic diseases. It has been provided, analytical chemistry has provided an important basis for modern technology and chemical development. So in the earlier point we have discussed, suppose one organic compound is prepared by a old method in which we are getting 60% yield. Suppose we have carried out the research, and if we developed the modern technology or the modern method which gives higher yields, then we can switch over to the new method in which we are getting the higher yield of that product. So this is possible only when we carry out the analysis, and we brings about the changes in the methods that are employed for the synthesis or for the production of different chemical compounds. So this is the importance of analysis. Now the next point is analytical processes. So while discussing the syllabus, we have mentioned qualitative analysis, which is nothing but the identification or detection of constituents of the analyte. Which constituents are present in the analyte? Detection of these constituents is nothing but the qualitative analysis. The second process, quantitative analysis, determination of amount, which is also called as estimation, or determination of percentage of constituents of the analyte. This is nothing but the quantitative analysis. Then structural analysis. After qualitative and quantitative analysis, we come over structural analysis, in which we come to know the structure of the chemical compound. So structure of chemical compound is always essential. It is always required to know, because different chemical reactions shown by that compound depends upon the structure in which different atoms or groups are there, functional groups are there, and looking at the structure we can have different advantages of that compound. So structural analysis is important. And last one is the instrumental analysis. So by using different instruments we can analyze, we can find out the constituents, their percentage. Means we can carry out qualitative as well as quantitative analysis by using different instruments. For example, if we have the organic compound, and if you want to find out the functional group present in the organic compound, just take the infrared spectrum of that organic compound, and you will come to know which functional group is present in that organic compound. So after knowing functional group, we can say what sort of reactions that compound can show. So this is the importance of instrumental analysis, and it is the advanced technique. Instrumental analysis is the advanced technique, and it is superior over the chemical techniques. Also it takes less time as compared to the chemical analysis. The next point is methods of analysis. So if we have these samples before us, now the question arises, which method should be employed, which method should be used to analyze the samples. So there are different methods which are available to analyze the samples. So while analyzing the samples and adopting a particular method for its analysis, we need which property, which parameter is to be analyzed from the sample or analyte. So depending on these properties, depending on these parameters that is to be analyzed, there are different methods, or the methods have been classified based on different parameters. So the first first method of classification is analyte can be analyzed by various methods of analysis, which depends upon analyzing property. Which property is to be analyzed, and that decides the method of its analysis. So properties and methods of analysis have been shown in the following table. So let me zoom this one. So here the first column is of property, second column is of method of analysis. So if we want the first property, mass, if we want to analyze mass of the compound, mass of the substance, then we have to follow the gravimetric method of analysis. If you want to analyze volume, then volumetric analysis should be followed. If we want to know the conductance of the given solution, we have to follow the instrumental technique, which is called as conductometric analysis. If you want to analyze the electrical potential property, then we have to use potentiometric technique. If you want to analyze absorption of radiation of particular sample, suppose sample is there and it is irradiated with the radiations, so to what extent that sample has absorbed the radiations. So absorption of radiation by that sample can be analyzed by absorption spectroscopy. There are different absorption spectroscopic techniques. Generally it is called as absorption spectroscopy because there is absorption of radiation. Emission of radiation. If suppose radiations, if particular object or particular substance is bombarded with radiations, some will get absorbed, some will get emitted. So to what extent the radiations are emitted? So emission of radiation by that sample can be analyzed by emission spectroscopy. Scattering of radiation. The radiations which are bombarded over the substance get scattered. So to what extent they get scattered? This can be analyzed by using a Raman spectroscopy, turbidimetry, nephelometry. Different techniques are there. So these are depending upon the properties, we can employ the method of analysis will depend upon the property that is to be analyzed. So this is the first classification. The second classification is based on the modern analytical chemistry, is suggested by the modern analytical chemistry, and it has divided the analysis methods into the two categories. The first one is chemical methods and second one is physical methods. In chemical methods, measurement of mass or volume is carried out, whereas in physical methods, measurement of physical parameters related to the amount of the component is carried out. So this is the modern analytical chemistry classification, which is classified into chemical methods and physical methods. The third classification is based on the properties of the substances. Properties of the substances. Analysis methods have been classified into three classes. So based on properties of the substances, the analysis methods have been classified into three classes. So again, first is chemical method, which depends on chemical reactions. Second one is physicochemical method, and third one is physical method. So these are the three methods: chemical method, physicochemical method, and physical method. So chemical method depends on chemical reactions. Again, there are two parts: qualitative analysis and quantitative analysis. Identification method involve formation of colored solution, precipitate, evolution of gas that indicates that constituent is present in that sample. So identification, when we say particular constituent or particular element is present, if we get the colored solution. if we get the precipitate, if there is evolution of gas, we can say that that element is present in the sample. So this is how we can carry out the qualitative analysis under chemical methods. Quantitative analysis involve measuring reaction products from the reagents consumed. Quantitative analysis, determination of amount or determination of percentage of the substance. Suppose A and B reacts and they form C and D products. So we have taken A 5 grams, B 5 grams. The total amount of reactants is 10 grams. And we are interested to prepare C product. We are not interested in the D product. If we are getting C product 8 grams and D 2 grams, so C is the product of our interest, which is obtained in 8 grams. So as compared to 10 grams of reactants, the amount of product C that we receive is 8 grams. So the percentage yield of the reaction or the percentage yield of the product C will be 80%. So this is how we can carry out the quantitative analysis just by measuring reaction products from the reagents consumed. B, the second method, physicochemical method. It involves measurement of physical parameters of a chemical system that depends on the nature of the system components and vary in process of reaction. Slightly it is difficult to understand what is the meaning of this physicochemical method. So first of all, make it clear, it is the measurement of physicochemical method is used to measure physical parameter. Now let's take the example so that it will be clear. For example, optical densities of colored complexes in spectrophotometry. Suppose A and B reactants we have added in the form of solutions. A and B solutions are mixed in a test tube and we want to record its optical density. So the physical parameter is that we are going to measure is the optical density. So as time passes, A will react with B and there will be formation of the product. Now A has some optical density, B will have some optical density, and the products C and D will have different optical densities. So as reaction proceeds, there is a formation of C and D, and after some time the reaction will get completed and we will obtain the products C and D. So as so this is the A and B system of components, and it vary in process reaction. As time passes, the product obtained will vary in its percentage. The more and more product will be obtained. So the optical density will also get changed. So here we are getting the measurement of physical parameter, that is optical density, which is a physical parameter of chemical system. So there is reaction between A and B, which is a chemical system that depends on the nature of the system components and vary in process of reaction. So this is the physicochemical method, the second classification, the second category. Quantitative analysis of substance is determined from the value of physicochemical quantity measured and the concentration of the desired component in the sample. Here by mistake it is OIN, it should be IN, in the sample. So in physicochemical methods we can detect, we can come to know the optical density. Now if we want to carry out quantitative analysis, then the physico-chemical quantity measured, that is optical density, is known to us, and if we know the concentration of the desired component in the sample, then we can find out the quantity of that substance. So here we should know the one physical parameter, for example optical density of that substance, and if we know the concentration of that sample, we can find out the quantity of that substance, that is we can carry out the quantitative analysis. So this is about the physico-chemical method. The third method is physical methods. In this method, composition of substance can be determined by measuring physical properties like densities, viscosities, etc. So in this method, composition of substance can be determined. Composition of substance means by which constituents that substance has been made. That can be determined by using physical methods, and here the help of physical properties like density, viscosities are taken. Similarly, spectral analysis is also an important physical method. All the spectroscopic methods which are based on physical principles, so these are the physical methods, and which are useful as compared to chemical or physico-chemical methods. Instrumental methods or spectral analysis is important, and it occurs in short time. So this is about the 3 points discussed so far. So if you have any questions or queries, you can ask me. Thank you very much.